Kilo 6 Lima Delta Echo. Kilo 6 Lima Delta Echo in Red Bluff, California, standing by. This is Kilo 6 Lima Delta Echo. Kilo 6 Lima Delta Echo in Red Bluff, California. Hello there, this is Elmer Ed here, Kilo 6 Lima Delta Echo. You've heard me quite a few times on the net and around on the radio. And I think you might have heard of me talking about putting in a waterfall display on my computer and on my radio. So I thought I would make this video to show you how I did it. And it's an informational video. It is not an instructional video. And what that means is that I'm giving you information of how I put it in my radio, but not how you would do it in your radio. So you can take what I give you and then apply it to your radio, because it's going to be a different circumstance and a different radio, and everything's going to be different, but you will at least understand what I did and how I did it. Okay? With that, we'll go now to the actual process. To do that, we're going to need 5 elements. We're going to need 5 things. We're going to need a radio. In this case, it's a TS450 by Kenwood. And then we're going to need a kit that is sold by, in my case, a kit that was sold by DX Engineering. And this is a little jewel right here. It comes with just a little circuit board and connecting wires, and that's all there is. The instructions that come with this are minimal, to say the least. They don't even tell you what the voltage requirement of this thing is. You are out there on your own when you get it. So the fact that I'm going to tell you what it can do is going to be beneficial to you on that aspect of it. Our third, we're going to have a SDR dongle. And a dongle is anything that you put on your computer to interface with the computer for whatever reasons. It's called a dongle. They don't necessarily have to be in this shape or whatever. This happens to be an RF dongle, or a radio frequency SDR, software defined radio. And it will accept radio frequencies into it and display it on the computer screen. So we will get to that later in the second part of the video. I have the dongle that we're going to be using is this one, because this one is kaput. It don't work. It's ready for the e-waste basket. And this one I had to get new, because this one does not have temperature compensation in it. And these things get hot. So this thing kind of went away when it got too hot on me, and I didn't realize what was happening. This one here is made in the United States. It is solid, it is great, it is temperature compensated, into the point where if it gets too hot, it shuts down, it turns off. So you can be in the process of doing something with it, and poof, it's too hot, it shuts down. So what I did was I took some TTT, which is temperature tolerant tape, and I put a heat sink onto it, and this then allows the heat to dissipate away from the radio. And I have run it now for 3 days like this without unplugging it, and it has not shut down on me yet. So this heat sink does work on this. This is what we're going to be using. Then after that, we have to have a connecting wire that will connect us from the radio over to the computer, which is on the other side of the room. And that will be in the second part when we connect up the dongle. And we also have the manual that's required by the radio. And it has fold-outs in here of the printed circuit boards and the schematics and everything that's in this radio. When we get to the point where we have installed this device and we get ready to connect it up inside the radio, you're going to need this, because this is going to tell you where in the radio you're going to connect this thing, okay? And it's very, very important that you have this. You can't do it without it. There isn't anybody that I know of that has that capability. This little device we got from DX Engineering, you're going to have to put it in there in a very secure manner where it won't flop around and what have you, and it won't short out to any other devices. It won't inject any capacitive reactants or inductive reactants into the radio and upset the tuning and what have you of it, because we're going to be into the tuner section or the RF section of it where it comes in from the antenna. And like I said, this is not instructional, so I'm not going to get into telling you how the radio works. I'm just going to refer to different things, and if it's necessary for you to really understand that, then I would suggest that you go to the manuals and to Google or whatever it's available to you to find that out. I will tell you this. Whenever you're going to tune a radio in, you're going to tune two things. You're going to tune the input RF amplifier into a specific frequency that you want to listen to, such as our repeater here locally. It's 145.11.0 megahertz, and we would tune to that on our radio. Now, when that signal comes into the radio, it's too loud. I mean, the frequency is too loud. We can't, in our human body, cannot deal with this frequency. So we're going to have to manipulate this frequency, and we're going to have to bring it down into frequencies that we can hear ourselves. And this is all done inside the radio. The first thing that we're going to come into is the RF amplifier. And from the RF amplifier, we go into what's called a mixer. Now, the mixer has two inputs. It has the input for the principal frequency that we're tuning to, and then we have the frequency of a variable frequency oscillator, or VFO. And this VFO is mixed, or a better word is, a technical word for it is heterodyne. These two frequencies together, and you're going to come out with a difference frequency called the IF, or intermediate frequency, that you're going to use throughout the remainder of the radio. And then the radio can manipulate that, and it gets to be highly technical, and this is a very simplistic explanation of what I just gave you. What we're trying to accomplish here today is to connect this device to that mixer, the output of that mixer, or that RF frequency, the intermediate frequency, and we are going to jot that frequency down because it's in the manual, but we're going to need it later when we set up the SDR and the waterfall display on the computer. In this particular case, in this radio, that intermediate frequency is 73.050 megahertz, and that's the one we're going to be connecting to in this radio, because that's the intermediate frequency that this radio uses. At this point, we're going to access the radio. Now, I've already taken this radio out, I've turned it upside down, and I've removed all of the screws out of it. And all I have to do now is to remove this cabinet, the top, off of this radio, and show you the insides of the radio. Okay, here we are with the insides of the radio, with the cover removed and what have you. Now, I have already determined that the part of the radio that we want is on the bottom of the radio, so I had already turned the radio over and removed all of the screws and what have you, and having this available to us. There is a whole different side of this radio on the top that you can remove the top, and there's a whole different side of the radio down there, but that doesn't pertain to what we're trying to do today, to accomplish today. And so we are here on the bottom side of the radio, and we're ready to go to work. But first, I want to explain one thing to you. Do not touch anything in this radio Do not juggle anything, move anything around, touch anything, experiment with it, or whatever. Or say, oh, this is cute, and touch it. Don't do that, because these things are so sensitive that you can upset the apple cart. You don't know what you're touching or what you're doing. Okay. Don't do anything more than what I'm going to show you today, and be as cautious as I'm going to try to show you today to be. Okay. All right. The first thing that let me explain to you is this is only one half the story. On this side of the board right here, you see nothing but coils and transformers. I have transformers and jacks and everything for you to plug stuff into and what have you on this side of the board. There are, with just a few exceptions, some SMT or surface mount technology devices here, transistor and a couple of resistors and capacitors and an integrated circuit and what have you. There's just a very few of them on this side of the board. There are, in this side of the board, there are at least 50 or 60 transistors that they are not evident here. You don't see them. That's because they are on the other side of the board. And they're put down in here, and using standoffs, they mount these boards in here, and you don't have access to the transistors. When we look into the schematic here in a few minutes, we're going to find out that there are transistors that we're looking for, and there are places that we want to connect to that's in relationship to transistors, and they're not available to us. So we are going to have to look for something that's available to us on this side of the board that relates to a point on the other side of the board where these transistors are located. And we have to find out where to put this little board inside this computer. Where do we have the ability to put it in here without disrupting the computer and without shorting and introducing interference to the radio? You can see that we have two open areas on this board right here that we can potentially use to our benefit. There is no other ways around this board here that would be easy to mount. We could make some brackets and what have you, and maybe stand it up in here like this or whatever, or lay it down on the top here or whatever, but that would be very hard to do. And so we're going to concentrate on using these open areas here if we can. Now we can see that this open area here won't work because the board will not fit in that open area. However, when we come over to this open area over here, it fits in there perfect. There's no problem whatsoever, so we're going to use this. Now these open areas right here are areas that's made available inside the radio for different options. This particular option right here is for a CW filter, and this option right here is for a single sideband filter, and this one over here is for a 455 megahertz filter. We're not going to be using them in the future, so they're available for us to use, and I'm going to use them. Now, in order to do that, you can see that this fits in here perfect, and that there are mounting screws on each end of this right here that is used when you put these filters in to screw the filters down and hold them in place. That's perfect for us, because in order for us to use these areas, we're going to use those screws. To use that, I have made a little bracket. And this bracket then will fit down in there, and it has a screw, because you see that this circuit board only has one hole in the circuit board for mounting. That board then will mount on that screw on this bracket, and we will take this bracket then and put it down inside the radio, and you can see how it fits in there perfect. Now we will take this little amplifier and we put it in there on that bracket, and you can see how that's going to sit in there. It's going to be perfect. So to do that, let's actually put this in now, and you can see how it works. Now I'm going to get my trusty little screwdriver here to put this thing in, and I'll get my my nut driver so I can put that board on. Now let's take the the board and put it onto the bracket first, and that'll go on just like that. Now we put this down into the radio. There we go. Sitting in there beautiful. So now we have a very, very snug, very tight fit of our little board into the computer. If you notice now, I have not touched anything in the radio. I haven't moved any wires. I haven't touched anything or anything other than just sit this down in and screw it in there, okay? So we haven't disrupted the operation of the radio. We are at the point right now where we're going to connect the wires up. And we'll do the easy part first. This is the power, and I've already put this in. That's already pre-put it in and located where the power is and soldered it in, and to save a little bit of time here of what we didn't need to do. And now we're going to plug this onto the board. Now you have to make sure that when you're doing this, that you're going to put the positive to the positive and the negative to the negative. So we've got the power connected up to it. Now we are going to connect the SMT, or the SMA. We drilled a hole in the back of the radio here to mount this SMA connector on, because this is what we'll attach the cable to the computer. This is pretty hard steel. And as you know, that when you're drilling, you press hard on that drill, and when it breaks through your metal, it has a tendency to protrude through the hole real fast. And when you can see all of this information that's in here, I call it information because these are coils and what have you, that's in this area right here in the RF portion of the input portion, filtering and what have you, of the RF amplifier. They're all in here, and it's very easy for your drilling, to go in and come in here too far, and that drill catch some of these coils and everything, twist them up, and your radio is ready for the e-waste bin at that point. I would suggest that what you do is you take different sized drill bits, such as a small or 1/8 inch drill bit or whatever, drill that hole through because it's much easier for it to punch through. Then you go to a different size, in this case 5/32, and you drill a little bit bigger hole. That will go there again. It will go through very easy because you've got this starter hole. And then when you get to the 1/4 inch drill bit that we had on the drill, then it has this starter drill, this 5/32 inch hole here, and it will go through much easier. So when you break through here, the drill probably won't come in much more than 1/4 inch or so, and you stand much less chance of damaging anything. So now what we're going to do is we're going to take this SMA connector, and we're going to actually put it through the hole in the back of the radio that we drilled for that purpose. And we will put the nut on the SMA connector. Okay, so that's on there really tight, and we've got our connector into the outside whirl installed. Now, this is where it gets kind of dicey. This is where you have to connect to the intermediate frequency part of the radio, and this is where you have to do some sleuthing to find out where it is in your radio and how to connect to it. Now, in my radio, I access the manual. We will go into now to the word circuit description of it, and we get into there and we find out in this word picture that there are 4 transistors, 14, 15, 16, and 17, that make up the first mixer that we are trying to get to. And this the first mixer is here, and then it goes into the filter, and then out to the second mixer and what have you. This is what's called a 3 conversion radio, and it has 3 IF frequencies. We are going to concentrate on the first IF frequency, which is a 73.05 megahertz. And to do that, we're going to access it at the first mixer. And that's where you take the principal frequency in from the antenna and the frequency from the voltage control oscillator, and we heterodyne them, I mix them together, we come out with a difference frequency on the output of the first mixer of 73.05 megahertz. That's where we're going to concentrate. That's where we want to pick that signal up at. So in order to do that, we go over here to page 144. We're going to go from the word diagram, the explanation of where we're trying to get to, over to the actual schematic of the radio to find out where we're going to go. This is the schematic of the first the RF amplifier printed circuit board, and this is where we're going to concentrate on today to find out where to connect to. And if you look right here real close, you'll find that there are 4 transistors there in a square. That's transistor 14, 15, 16, and 17. And you remember back in the word picture, it said that the output of the first mixer amplifier was these 4 transistors. And as I told you before, they're located on the opposite side of the board. They're not available to us. When we look past the output of this mixer, we find that there is an IF transformer. And this IF transformer is number 33, I believe. And then it transitions across over to another transformer, which is number 34. Now that is interesting because that's something that's on the same side of the board that we are working on, that we have access to, and so it's a potential that we could connect into there. And if we look a little bit closer, we find out right here that, lo and behold, there's a test point coming off here. Test points are pads or devices sticking up off the board for you to connect oscilloscopes to and what have you for repair purposes. This one is sitting exactly where we need it to be on the board right here, and it's test point number 1. So we are now going to go on the board and we're going to find that test point number 1. So we are extremely fortunate to have this available to us. We do not have to solder anything to the board. We don't have to do anything to disrupt the board. All we've got to do is to make a jack on a wire and plug it into the board. And we'll show you that in a second. Now this over here along this side of the board is where we put the RF connector, the SMA, in the back of the radio. And over here is where we put the little circuit board in this area here. So we have from here to here a very little short distance that we have to connect up to the IF portion of the radio to here. So let's go to the actual radio itself. This right here is the printed circuit board that we mounted. Over here is the RF connector, the SMA connector we put in the back. Now here, right here is the transformer, IF transformer we was talking about, and down in between the two is a little white connector down there that we can connect to. The only problem is where am I going to get this connector? Well, looking through my printed circuit, my junk box, lo and behold, I found a little white connector that I had in my junk box, and so I took this cable and put it together, and I heat shrunk the connectors together so they wouldn't short out, and I put it over here, and we will now just take this and plug it down into that little white connector. Just kind of delicate that we get it in there right, because we don't want to bend any pins or what have you. Now it's down and it fit in there perfect. Okay, now we make sure that these connectors are good on our board, because they just snap on both our connectors. Our power is plugged in, and the board is sitting here nice and secure. Nice, clean, secure installation without disrupting anything in the radio. We have these wires here that's not bothering anything at all, and they will just lay in there. We have at this point completed the installation. It's a nice, beautiful installation, secure. No wires getting in the way. We haven't disrupted anything inside the radio. Everything is clear. It's not shorting out. It's a visual inspection says that it is spot on, and we are ready to go with the RF connector here that will take this over to the software-defined radio, on it to the computer. We will now go and put this thing back together. So you can see we put the speaker back in, the antenna, and the power supply back on here. This right here is the SMA connector that's going over to the dongle onto the computer, and this is will supply the signal coming out of the radio over to the dongle, so we can see that work. And we're putting that on here right now. I've got an angle, a 90-degree angle bracket here, so that won't bind and cause the cable to break by bending it when I put it in here. So now we've got this thing in. We will slide this back around and put it into its little nook where it's supposed to reside. So now we have the radio done, it's back installed, everything's connected up. All we have to do is to flip the switch, and it's back on the air. Now we will take this little device right here, and we will connect the cable to the dongle, and we will take the dongle then and we will plug it into the computer. We got the radio all put back together and working on the other side of the room. We are now positioned at my computer, and we have installed the dongle over here into the USB port on the top of my computer. We are connected up, and the device that we installed now is connected to the dongle, and the dongle now is connected to the computer. And we are over now to see the waterfall display. At this point, I have to explain something. The device that we installed in the radio is not the waterfall display, okay? It is nothing but a signal from the radio going to the dongle, and from the dongle into the software that we got loaded on the program. The dongle, or the software-defined radio, and the software accompanying it is the waterfall display. You can connect a cell phone up, a laptop, anything that has an RF signal output into the dongle to provide a signal to activate the waterfall. Otherwise, it's going to be exactly like it is right now, which is static. It's running, but there is no signal coming in, so the waterfall is not working for what we want it to do. I'm not going to go into a complete explanation of the waterfall. I'm going to point out a few simple little things and then you can look up to explain how waterfalls work. I look at this as this, the top part of this screen is a lake or a river of water and what have you. And these little wiggly lines going across right here is the top of the water in that lake. At this dividing point right here is a dam. As the water up above the dam, as it raises up and down, it spills over and it goes down the waterfall here. So as you follow down the waterfall, you see some ripples and stuff going down the waterfall. This is past events that came from here down to here. You have timelines along the edges over here of the waterfall that tells you how long ago it was that this transitioned from here down to the waterfall. So if you just look at it as being a lake of water or what have you that spills over the dam and goes down the waterfall, that's pretty well explains the waterfall that you're having. There is a lot more going on here other than that. Before we go any further in our explanation of the waterfall, I want to backtrack a little bit and give you some information. This right here is the information from DX Engineering on the dongle. I'm sorry, not the dongle, on the kit that we bought from them to put in the radio, the buffer amplifier. It is very, even though it's a little over a page of information, it's mostly about their dongle and what have you, and it has very little information, very skimpy information about the device itself, like what is the maximum voltage it will take, where do you connect it up in the radio, and what have you. So when you get this is what you're going to get, and you hopefully with this video right now and me explaining it to you, the maximum voltage, by the way, is 14 volts on this thing. You can be successful with it, but I had to dig it up off the internet and to get that information. As far as the software goes, it makes this dongle work and this whole process work. There are multiple types of software that's free on the internet that you can download. And this right here is the AirSpy. And if you can see that word right there, AirSpy software for the SDR Sharp or their dongle that they sell, the AirSpy dongle, but their AirSpy software will work with almost any dongle. So I downloaded it, and that's what we're using on this on my waterfall display here. Well, as you can see here on the screen, the waterfall display is an extremely complex display, and you can get so much out of it if you know what to look for. The one thing that I want to point out right now is the different modes that you can monitor while you're in this display. Over on the side over here are the modes that you can select. At the moment we're in what's called narrowband FM or NFM. And this delineates the width of the bandwidth of the FM signal that we're recording. It's narrowband because it doesn't require too much of a bandwidth to just convey voice. So narrowband bandwidth for FM is used mostly in ham radio and what have you. Don't confuse this with narrow in fusion radio, what have you. Research that, see if there is a difference between narrow FM in fusion and in this general ham radio. Now we've got a wideband FM, and you can see that it covers pretty well the whole screen. And that's because that wideband FM is used by commercial radio stations to play music and what have you. And in order to do that, they require a much wider bandwidth to transmit their music and what have you, on the order of 15,000 cycles per second, whereas narrowband FM requires much less to just convey voice and what have you. Now you get to AM. AM is going to have a little bit wider bandwidth, on the order of maybe 10 kilohertz, and you can see over here, you can see when I put it there, it says bandwidth of 10 kilohertz. Okay, we go back to wideband FM, and it doesn't show a bandwidth, because there it gets bandwidth of 200 kilohertz for wideband FM. And when you go into the narrowband FM, then we're going to show a bandwidth of only 8 kilohertz. So this establishes the different modes and the bandwidth for those modes. Now, if I want to adjust this bandwidth here, I come over here and I find out it's still 8 kilohertz, but the display has changed down here to show a much wider display. But the actual bandwidth for that mode of transmission is still 8 kilohertz. And when you get to AM, and you come over now, you find out the bandwidth is 10 kilohertz, and double sideband, you come over now and you got a bandwidth of 6 kilohertz. So study the difference between double sideband and the rest of them, and you will better understand that. The lower sideband is here, and you see that you've only got a bandwidth of 2.4 kilohertz for lower sideband. I think when you were studying and what have you for your license, it mentioned something like 2.8 kilohertz, but you can see on this waterfall display it's 2.4 kilohertz. Over here on the upper sideband is the same way, upper side bandwidth of 2.4 kilohertz. And when you get down to CW, you can see that you pull up a bandwidth of only 300 hertz, because that's all that's required by the bandwidth for CW is the 300 hertz, just to send dots and dashes. Okay, and when we get to raw, we got a 10 kilohertz bandwidth for raw, and raw is a little different than the rest of them, as where they're all different. But I just wanted to show you here how you can see the bandwidths and the sidebands and what have you on the waterfall display, and how you can learn from that. Okay. The other thing I want you to pay attention to is up here is the frequency of the center signal here, the red part here, that we are going, the signal you're going to be listening to. And here it says 73100. That's because when you click on the wideband FM, it automatically resets it to 72100, because the stations are located 100,000 cycles per second apart from each other. And so you're not going to listen to wideband FM and listen to any stations closer than 100 megahertz to each, 100 kilohertz to each other. So we'll switch this back down now to narrowband FM, and we will go back to our frequency that we're monitoring on the HF radio. Over here, you're going to see that we can change the bandwidth that we're going to display. We're going to look at the display, and we're going to increase the bandwidth so we get more definition of that signal and the sides of that signal. However you look, you can see that on narrowband FM, it's still at 8 kilohertz. And we have just changed the frequencies down here on the bottom to show. It's sort of like doing a zoom in and a zoom out of that band. So we can zoom real narrow, or we can zoom way out to look at the frequency that we are monitoring. and on the range you can change the display on the lower part down here, and on the offset you can raise and lower the height of the water that you're looking at in the river here. And it's very interesting. It's very complex, a very interesting display here, the waterfall display, and it will show you a lot more about your signal than you're getting by just looking at some numbers on the screen on your HF radio. Right now I'm going to show you some videos that I have recorded of the signals coming in. Okay, this little video that you're looking at right now, I recorded off of the 73050 megahertz from the HF radio, and you can see that there is a very pronounced area and on the display of the frequency that we're listening to, which happens to be a commercial AM radio talk show that I recorded off the AM band, and it's flowing down across the screen down here, and I just wanted to show you that from the HF radio and this waterfall display, and see it working from that aspect of it. We can record on the waterfall display strictly off of an antenna, and we don't have to come from a radio or whatever. And this you can see is the 511 repeater in the Reading area that we're recording from. The one thing that I'm pointing out to here on the waterfall display is these bandwidths and the visuals that you get off the waterfall display of the bandwidth and what have you is very instructional for you to understand bandwidth and sidebands and things of this nature. So the waterfall display has a lot more information into it, and I've just scratched the surface. So it would benefit you to get into some method of instruction that would tell you how waterfall displays work, because they give you a lot of good information. We are at the end, and with that, I will bid you fine adieu and pass my 73s along to everyone. This is Kilo 6 Lima Delta Echo, or Elmer Ed, and we're signing off. Adios.